matters in agent systems. So tool integration, it transforms an AI from a thinker into a doer, because without tools, AI is just a thinker. Large language models can give you some very good strategies. It can do the planning for you. But with tools, with tool integration, it can also execute those strategies. So with tool integration, AI becomes doer. So tool integration transforms an AI from a thinker into a doer. And if we talk about agents, AI agents are not just LLMs. AI agents, they become powerful when they can call APIs, when they can execute code, when agents can access databases, and when AI agents can interact with the real world systems. So the real power in AI agents is when they can act, they can call APIs, they can execute code, they can access databases, they can interact with the real world systems. And in, like, if we talk about the workflows in agentic systems, we can have a modular workflow and also a hard coded workflow. So it will decide the agility factor. Whether you are using a modular workflow or a hard coded workflow will decide the agility factor. If we talk about hard coded workflow, so hard coded workflow means it is predefined, and no matter what kind of uncertainty the system will see, it will remain fixed. It will not adapt. And since it will remain fixed, it is rigid, it is slow to change. So hard coded workflows, if we talk about, they are rigid, slow to change. On the other hand, if we talk about modular systems, modular workflows, the good thing about modular workflows is that they can adapt themselves. So they are flexible, adaptable, and agile. So the most significant architectural shift in agent systems is moving away from hard coded workflows and moving towards designing modular workflows, modular systems. So now let us compare hard coded systems with the modular systems. So hard coded systems is like the old way of designing applications, designing systems. But if we talk about the agentic AI systems, they follow the modular systems. So the agent way is the modular tool systems. Now we will compare both of these, the hard-coded systems with the modular tool systems, by considering several features. So if we take into consideration the logic feature, so in terms of logic, hard-coded systems, it follows a fixed if then statements. If this, then that. If this, then that. But if I talk about modular tool systems, in terms of logic, it follows dynamic reasoning based on intent. It follows dynamic reasoning based on intent. So in modular tool systems, there is no fixed rules, rather based on the intent, in the real time, on the fly, it will decide what to do. And this dynamic reasoning based on intent makes modular tool systems very powerful. Any uncertainty very easily it can handle. It is, and this dynamic reasoning makes it very flexible, adaptable, and agile. Rather, and the fixed if then statements, the fixed rules of hard coded systems makes it very rigid. Now, if we compare hard coded systems with the modular tool systems in terms of flexibility, so hard coded systems, since they are based on the fixed rules, they breaks if the user deviates from the script. Like hard coded systems, they cannot handle any uncertainty. If there is any uncertainty in the system, the hard coded system will break. But if we talk about the modular tool systems are very flexible. They adapt to unique or unexpected requests. So modular tool systems, they are flexible, they can handle uncertainty. The reason for that is that based on the current intent, it will make a plan. The modular tool systems, it does not follow a fixed plan. Rather, based on the current input and the current intent, it will make a plan. And because of that, it is flexible to changes. It adapts. This makes it very powerful. Now, if we compare hard-coded systems with the modular tool systems, and if we consider the maintenance feature in terms of maintenance, if we look at the hard coded systems, they require a developer to change the flow, because the idea is that it is based on the fixed rule. Now, any changes in the business logic or any changes in the system, that requires a developer to change the flow. There is a need to change the fixed rules. But in modular tool systems, for maintenance, we just have to add or remove a tool from the box. So in modular tool systems, for maintenance, we simply need to add or remove a tool from the toolbox. It will be so easy. Now, if we are we are comparing hard coded systems with the modular tool systems. And if we look at the scalability aspect, so from the scalability aspect, hard coded systems, since they are based on fixed rules, they are not at all flexible. And as we try to scale hard coded systems, they become more and more messy. So hard coded systems, they becomes a spaghetti code mess as it grows. So that's a shortcoming of hard coded systems. But if we talk about modular tool systems, so if we talk about the scalability of modular tool systems, they're highly scalable, because the reason is that very easily we can plug and play new tools, and AI will decide which tools to use. So as the system grows, like AI will be able to handle the uncertainty, because modular tool systems, we already saw that it is very flexible. It can handle uncertainty. It is based on the dynamic reasoning, based on intent. So no fixed rules in modular tool systems. The rules are decided on the fly. This makes it very scalable, highly scalable. So modular tool systems are highly scalable as compared to hard coded systems. So from all these discussions, it is very clear to us that hard coded workflows, since they are based on fixed rules, they are rigid systems. Hard coded workflows are rigid systems. But if we talk about modular tools, modular tools, they are adaptive systems, because modular tools, they are based on dynamic reasoning, based on the intent. So since the planning is done in the real time, no fixed rules, it is very flexible and it is adaptive. So modular tools are adaptive systems.